Hello students, welcome back to our channel Diksha Karnataka. So as you know, we have started a series where we are solving the top 30 questions from all the important chapters. So we have already done for many important chapters like solutions, kinetics, electrochemistry, coordination, DNF block. You can watch them. So in this video, I'll be discussing the top 30 questions from the chapter Aldehydes, Ketones and Carboxylic Acid. So this is a high weightage chapter and you can easily expect 3 to 5 questions from this chapter. So please solve these questions, and if you are able to solve this question, you can assure that this chapter is done for your exam. The questions here are very similar to your KCET exam questions. So let us start with the first question. Okay. So this is a reaction based question where we have this CH3CH, double bond CH and then CH2OH. So I'll be also telling you the reagents, so we can revise the reagents once here. PCC is the reagent given, so you might be knowing that PCC is a reagent which is a mild oxidizing agent. Okay, what is the work of this one? It converts alcohols to primary alcohols to aldehydes. Okay, so the question here is not about the reaction, it is already given the product. It is about hybridization. So the question is asked, the hybridization change involved in carbon 1 in the above reaction. So this is your carbon 1. Here if you see, it is sp3 carbon, and now in the product we have CH3CH, double bond CH, C double bond OH, right? So this carbon here is sp2 hybridized, right? So the hybridization of carbon has changed from sp3 to sp2. So the correct answer for this question will be option number B. Okay, now let us see the next question. Again a reaction based question. So we have here C6H5Cn. Then it is treated in presence of SnCl2, HCl and then acidic water to give you X. Now this X is treated with concentrated KOH to give you Y plus Z. Okay. So now the question is, what is the formation of X, formation of Y and Z are known by. So this is directly name reaction question. So first of all, SnCl2 and HCl, this will reduce this one to C6H5. CH2NH2. Okay, so this is a Stephan reduction reaction. You can see only one option is having Stephan reaction, so the correct answer will be option D. But let us see the next part also. So concentrated alkaline medium, whenever you take, you must remember one of the very important name reaction, that is Cannizzaro reaction. So Y and Z will be, one will be your oxidized product and another will be your reduced product. So if we have this one, so this one will be your Cannizzaro reaction. Okay, so the correct answer for this question will be option number D. So after getting this C6NH, CH2NH2 and hydrolysis, this will be converted to Benzaldehyde. Okay, so this Benzaldehyde then undergoes the Cannizzaro reaction to give you Y and Z. So I can also write the product for you. Here we'll have C6H5, C double bond O, O minus Na plus. This is the oxidized product. And the reduced product will be C6H5 CH2OH. Okay, so this is the final answer. We have discussed this important reaction here also. Now let us go to the next question. Ethanoic acid undergoes this HBZ reaction, but methanoic acid does not, because of. So this is the reason you have to find out. It is the presence of alpha hydrogen. Okay, what is the condition for HBZ reaction? We should have alpha hydrogen. So absence of alpha hydrogen in ethanoic acid, that is wrong. That is presence of alpha hydrogen. So this option is incorrect. Next, higher acidic strength of ethanoic acid than methanoic acid. There is nothing related to the acidic strength. Presence of alpha hydrogen in methanoic acid. This is also wrong. So which is your alpha hydrogen? Just see here. If this is my acid, this functional group, the carbon attached to the next the functional group carbon is called as the alpha carbon. And the hydrogen attached to the alpha carbon is called as the alpha hydrogen. So in methanoic acid, we do not have any alpha hydrogen, but if you check ethanoic acid, see this is the carbon which contains the functional group, and the carbon attached to this one is the alpha carbon. So the hydrogen attached here is the alpha hydrogen. So because of presence of this alpha hydrogen, HBZ reaction takes place in ethanoic acid. So the correct answer for this question will be option number D. Okay, next. The general name of the compound formed by the reaction between an aldehyde and alcohol. So this one is like this. If you have any carbonyl compound, okay, and then we treat it with any alcohol, we get this compound RCOR R dash dash, right? So now this part is your acetal form. Okay, so the correct answer for this question will be option number D. Now this is, if you add one more R group, we will get RCOR1, then again OR1, and here we will have R dash. So this is actually hemiacetal form, and then after reacting one more group we get it acetal group. So hemiacetal option is not there, so the most probable answer will be your acetal group. So now let us see the next question. So this question is from your nucleophilic addition. This is an important topic. We have the addition of CN, addition of alcohol, sulfonic acid, ammonia derivative. So please prepare this topic thoroughly. Okay, next is again reaction based question. Reaction by which benzaldehyde cannot be prepared. So we have to prepare benzaldehyde. So this is the structure of benzaldehyde. So first reaction, this can be prepared. It is similar to Itard reaction. Then we have benzyl chloride with H2 and palladium barium sulfate. This is Rosenman reaction. This one can also be prepared. Benzene with COHCl and anhydrous AlCl3 can also give you benzaldehyde. But if you see this one, benzoic acid is there. And then if you treat it with zinc amalgam and concentrated HCl, that is your Clemmensen reduction conditions. So here we will not be forming the benzaldehyde. We will get reduced and we will get alcohol. So the correct answer for this question will be option number D. Okay. Next one. The test to difference between pentane 2ON and pentane 3ON. So first we have to write the structure. So this is pentane 2ON and then we have pentane 3ON. Okay. CH3 pentane 3ON. So whenever we have same functional group, just you have to remember the answer can be iodoform test. So I'll be telling you two conditions for iodoform test. First of all, the compound should have CH3CO group. Okay, if this group is present, okay, then that compound can show the iodoform test. Or else one more thing is can be present, that is CH3COH. Okay, so if these two groups are present in any compound, they will give you the test of iodoform reaction. Now you can see this CH3CO group is present in pentane 2ONE, but in pentane 3ONE it is not present, right? So we can differentiate them based on iodoform test. So this one will give you a yellow precipitate, whereas this one will not react. So the correct answer for this question will be option number B. Okay, next question. An organic compound X on treatment with PCC in dichloromethane gives the compound Y. So when you read such statement based question, read each statement and write down the reactions so that you can easily do it. So we have X and then it is treated with PCC to give you Y. Now compound Y reacts with I2. So this is again your iodoform reaction in any alkaline medium to form yellow precipitate of trichloromethane. So we get triiodomethane. So CHI3 is formed. The compound X is. So first of all, based on the options, we can easily do it. See, whenever PCC is taken, we have studied that primary alcohols are converted to aldehydes, right? So this one must be one aldehyde and this X has to be one alcohol and it has to be a primary alcohol. Now, if you see the option, this is aldehyde, it will not further react with PCC. This is ketone, this one will also not react. The only option left with alcohol group is option number C. So the correct answer will be option C. So so now we can write down the reaction. It is CH3CH2OH. When reacts with PCC, we will get CH3COH, right? Now you see this part is having CH3CO group, so it will show the iodoform reaction. So we will get this yellow precipitate. So the correct answer for this question is option C. So even if you don't know the second part, but you must be knowing that PCC reacts with primary alcohol. So the correct answer will be option C. Okay, now let us see the next question. So we have this first CH3COOH, okay, and then it is reacted with SOCl2. So we know OH will be replaced by Cl group. So I will be getting here CH3COCl. Then it is reacted with benzene in presence of AlCl3. So we will get this one So this is Friedel-Crafts acylation. We have studied this reaction from the very first chapter. So the product here will be benzene with COCH3. Okay. Now after this, so this is our A. This compound we got here is A, and then after reacting with benzene we got this is B. Now after that it is treated with HCN. So nucleophilic addition will take place. So here the compound we will get it, I'll change here. We will get OH and then CN. So we will get here OH and this one will be CN. Now when you do hydrolysis, this CN will be getting converted to acetic acid. Sorry, will be converting to the carboxylic acid group. So here it will become now COOH. Okay. So the correct answer for this question will be option number D. Okay. Very easy reaction based questions are there. Next question. Okay, we have the same product for all the three reactants. Reagents are different, so we have to identify the reactants here. So first of all, HgSO4, H2SO4 and ethyl acetaldehyde. So you should know HgSO4 and H2SO4 reacts with unsaturated carbons, right? Unsaturated hydrocarbons. So now, so that is why we can eliminate A and B, right? So answer can be either C or D. So ethine will give you acetaldehyde. Now just now I told you PCC will react with primary alcohols. So here ethane nitrile is there, that cannot be there. So this one has to be ethanol. Now if you treat with ethane and nitrile and hydrolysis, we will get this one. So the correct answer for this question is option number C. So if you know all the reagents, all the reactions, the questions are very, very easy. So just prepare and revise all the reactions again and again. So now going to the next question. Reagents which can convert this to this. So what is the conversion happening? We have an acetic group and then we are getting it to alcohol. So that is reduction. Okay. And we must know that reduction of, if we have acid group, it can be reduced only by LiAlH4. But if you have ketones group or aldehyde group, we can use in this case LiAlH4 and we can also use NaBH4. So the point here is any acid group cannot be reduced by NaBH4 because it is a mild reducing agent. Okay. So the correct answer here will be lithium aluminium hydride. Next question. Which is the most suitable reagent for the following conversion? So if you check what is the conversion here, we have COCH3. This part, okay, is getting converted to COOH. Means that there is a breakage of the molecule here, the bond has cleaved and we have got acid here. So this type of cleavage doesn't take place in tolerance reagent. Tolerance reagent can give you, but tolerance reaction generally is with aldehydes. So ketones will not react. So this one cannot be the answer. Then benzoyl peroxide, no such reactions we have, but I2 and NaOH. So the condition is if any CH3CO group is there, it will react with I2 and NaOH. And the bond will break here to give you iodoform and the respective salt. So the correct answer here will be option number C. Okay. Again, SN and NaOH, we don't have any such reaction. Now let us go to the next question. Okay, so if you have remembered, this is the most important preparation method of phenol. So the product A gives white precipitate when treated with bromine water. So this is your cumene process. So we will get here, if you treat this one with bromine OH, so when you treat it with bromine water, so OH is a highly activating group, so there will be replacement of H in the 3 positions. We will get 2,4,6 tribromophenol, right? This is the product formed here. Okay. So now the question is the product B is treated with, so we have another product here. So if you remember, product B will be acetone group. Okay. So product B is treated with barium hydroxide to give product C. So what is this barium hydroxide? This is very important name reaction, that is aldol condensation. Okay. So we have to write the product of aldol condensation. So here we have a trick how we can write the product easily. So just see here, if we have this one, CH3COCH3. This is my product B, and you have to write the product for aldol condensation. So just you can write the, this is self aldol condensation, so we can write down the two products two times. Now you have to check the alpha carbon of one of the group. So this is alpha carbon. This alpha carbon should be connected to the carbonyl carbon of the another molecule. So this is carbonyl carbon, okay, and this is alpha carbon. So just you have to connect it, then you have to break the bond here, and the one H you have to remove from here. We will get CH2, and here we will get OH. Okay, so alpha hydroxy aldehydes or ketones will be forming. So the final product will be CH3 CHOH. This is connected to CH2, and then we have CO, and then CH3. Now this is also heated, so because of heating there will be dehydration. So OH and H will be removed, and we will get a double bond here. C double bond O, and then CH3, right? So we will get the compound here 4-methyl pent-3-en 2-ONe, right? So the correct answer for this question will be option number A. Okay, next question. Okay, here one more CH3 is there. So 4-methyl pent-3-en 2-ONe. Now let us see the next question. Again, this question is from same, that is aldol condensation. So we have this benzaldehyde. Okay. So benzaldehyde doesn't have any alpha hydrogen. It cannot behave as a nucleophile. The nucleophilic attack will be from the other compound. So we will have CH3 COH. So we can just apply the trick here again. Just connect the alpha carbon of one of the compound to the carbonyl carbon of the other compound. So this one will be connected here. Now remove one H from here and add there. We have this CH2, and then here it will be OH. Okay. So after this, if we have the products, you can see are having double bond. So it will be giving you this product. We have this C, OH, H, CH2, C double bond O, H. Okay. So now here there will be dehydration. So I will get a alpha beta unsaturated compound. Okay. C double bond O, H. So just we can check, this will be the answer. So the correct answer for this question will be option number B. Okay, now let us see the next question. The carbonyl compound that does not undergo aldol condensation. So many questions are asked from aldol condensation. The condition for aldol condensation is presence of alpha hydrogen. So we can see this compounds, it is dichloroacetaldehyde. So what is the structure here? So this is dichloroacetaldehyde. This is one. So you can see here one alpha hydrogen is present. So this one will show aldol condensation. So the question is which one will not show. So now let us see the next option, trichloroacetaldehyde. So trichloroacetaldehyde is this one, right? So this one is not having any alpha hydrogen. So this compound cannot show aldol condensation. So the correct answer for this question is option number B. Okay. So now let us see the next question. Which is the most suitable reagent for the following conversion? Again, this is very similar to what we have already solved. This part, CH3 is getting converted to OH, right? One carbon cleavage is there. Carbon-carbon bond is there, that is breaking. So that takes place in presence of iodoform reaction, I2 and NaOH. So the correct answer for this question will be option B. So already we have discussed a similar question. Next. Okay, so here we have been given with products, reactant, and you have to just identify the reagents. So here it is very important to mark something. First of all, NaBH4, okay, can only reduce ketone groups or can reduce aldehyde groups. Okay, so first of all, this one you have to keep in mind. Next, if we compare with LiAlH4, okay, this one can reduce your acid groups, and it can also reduce ketone group and can reduce aldehyde group. Okay, now we have one more reagent here, hydrogen and palladium. So H2 with palladium can reduce double bond also. Okay, so now let us see this one. In the first option, see what are the two things that have the probability of getting reduced. One is your double bond here, okay, and one is this CHO group. Okay, so this CHO group in the product A, what you see, only this CHO group is reduced, double bond is not reduced, right? So for reducing CHO group, we can take so in the first option we have H2 palladium and NaBH4, right? These are the options. So we cannot take H2 palladium, right? If H2 palladium is taken, then what will happen? The double bond will also get reduced, which is not there in the product. So the correct answer cannot be A, cannot be D. Done. This part is clear. In this point, what has happened in product A, the double bond is intact, it is not reduced, right? So we cannot use hydrogen palladium because I told you just now hydrogen palladium also reduces the double bond. So that is why we can eliminate A and D. Now coming to option number B. In option number B, if you see this last alcohol group, okay, this alcohol group has been converted to aldehyde group, right? So if this conversion is happening from primary alcohol to aldehyde, that is done by a very common reagent, that is PCC. So the B has to be PCC. So this is B. So this one is also incorrect, right? Now you see the third option. In third one, what has happened? This double bond is reduced and this carbonyl group is also reduced. So which can do that both, reduce both, that is your hydrogen and palladium. So the last one, C, will be hydrogen and palladium. So the correct answer for this question is option number C. This is very important question to understand the reagents, their functions. Same reactant you see, if you just change the reagent, so many different products we can get. Okay, so I hope you all are getting this question. Let us go to the next question. Okay, propanoic acid undergoes HBZ reaction to give chloropropanoic acid. The product obtained is, so we had this acid before, COOH, right? In propanoic acid, when you could treat with HBZ reaction, we will get this one, right? Now the question is asking whether this is more acidic or this is more acidic. So if you see, chlorine is an electron withdrawing group, right? It has -I effect. It will stabilize the conjugate base better. So this product is more stronger acid than this one. So is stronger acid than propanoic acid. So the correct answer for this question will be option number A. Okay, very easy one, this one. Okay, now coming to this one. P on this one gives you, so we have P with hydrogen, palladium, barium sulfate. Something is produced which is Q. Now Q on concentrated NaOH is giving you R plus S. So when you see two products and concentrated NaOH is there, so you can easily guess it is Cannizzaro reaction, right? So Cannizzaro reaction means Q should be something which do not have any alpha hydrogen. Now from where so the question is to find P, right? So if you can guess this reagent, very common reagent. So this is your Rosenbond reaction. So we will get this one, right? C6H5. If we take COCl and then treat it with this one, we will get benzaldehyde. Benzaldehyde on concentrated NaOH will give us benzoic acid or salt of benzoic acid, and we have benzyl alcohol, right? Okay, so the correct answer for this question will be option number C. Now let us see the next question. Which one of the following compounds undergoes haloform reaction? So I have told you two conditions. Again, I'll repeat. So there are two conditions to check whether a compound can undergo haloform reaction or not. So the first condition is it should have this group. Okay. Rest, whatever is here, we are not worried. The only condition is this part should be present. Another condition is this group should be present. Okay. Here again, we are not worried what is there. If these two things are present, then it will show this haloform reaction. So if you see first compound, so the question is asking you have to tell which one will undergo. So you can see the first option only will undergo, right? Why? Because we have this required group here. Yes or no? Right? This one is there. So this one will help to undergo the haloform reaction. So the correct answer for this question will be option number A. Very direct and easy question. Okay, now let us see the next question. The appropriate reagent for the following transformation. Important question. Okay. We know this C double bond O is getting added, changed to 2H, right? That is your, either it has to be Clemmensen reduction or it has to be Wolff-Kissner reaction. Then, but you see in the question both the options are given. So how to identify this one? See here. Here we have this OH group, right? If you take any HCl, okay, so what happens here is this OH group reacts with this H plus and this Cl minus acts as a nucleophile and it can attack here. So what we may get is, there is a probability to get this product. We have this OH, C double bond O, CH3, right? Now when you treat it with HCl, this O plus will get removed and we'll get chlorine and CH3. So there is a possibility of getting this product also. So it may not be obtained as a pure product. So that is why the correct reagent in this case will be your Wolff-Kissner reduction. The correct answer for this question is option number B. Okay. Now let us see the next question. In the following reaction, what is the compound Z? So you can see very easy one, this one. CH3 is there. When you treat with CrO2, Cl2 and CS2, we will get benzaldehyde. Right? Now benzaldehyde is taken in presence of H plus. So CrO2, Cl2 and H3O plus total. So here one, we get this one intermediate of chromium is formed, right? Intermediate of chromium is formed. After that, when you treat this one, we'll get benzaldehyde. So the correct answer for this question is option number B. Okay, here one step is there. After this one, if you take H3O plus, we will get benzaldehyde. Okay. Next question. Lower members of aliphatic carboxylic acid are soluble in water. This is due to. So whenever solubility in water comes, the most important reason is hydrogen bonding, and acids can form very strong hydrogen bond. So that is why, due to the formation of hydrogen bonds in water. Okay, the correct answer is option number A. Very easy one. So now let us see the next question. Reduction of ketones cannot be carried out with which of the following reagents? So let us check the option. NaBH4, that is there, it can be done. Now zinc amalgam, that is also can reduce your ketones, that is your Clemmensen reduction. This is your Wolff-Kissner reduction. Hydrogen in presence of palladium, but when barium sulfate and quinoline is there, okay, it reduces, it acts as a poison. So option A is the correct answer. Okay. Now let us see the next question. In the following sequence of reaction, we have to just find out the product here. First of all, CH3Br is treated with KCN. So we will get CH3CN. Then when you treat it with H3O plus, it will be converted to acid. Then when you do with lithium aluminum hydride, we will get ethyl alcohol, right? The correct answer for this question is option number B. Okay, next. Cannizzaro reaction is an example of auto-oxidation. So what is the condition in Cannizzaro reaction? It should not have any alpha hydrogen, right? The aldehydes or ketones should not have any alpha hydrogen. So it is a typical reaction of aliphatic aldehydes. It's nothing like that. It is a reaction answered by only aldehydes not containing alpha hydrogen. Yes, this is a correct. It is a reaction answered by only aldehydes not containing alpha hydrogen. It is a reaction answered only by aromatic aldehydes. No, nothing like that. Formaldehyde can also give you Cannizzaro reaction. It is a reaction answered by aldehydes, right? So the most appropriate answer for this question is option number B. Okay, next. Okay. Benzene carbaldehyde is reacted with, so let us see here, benzene carbaldehyde is nothing but benzaldehyde, okay, is reacted with concentrated NaOH solution. So you know this is Cannizzaro reaction, concentrated NaOH to give two products A and B, okay, we have A and B here. The product A can be used as a food preservative and product B is an aromatic hydroxy compound where OH is linked to sp3 hybridized carbon. Okay, so one product is this one and another product is given as OH is linked to the sp3 hybridized carbon atom next to the benzene ring. So we can draw like this. One of the product is this one. You can see the definition. Product B is an aromatic hydroxy compound where OH is linked to an sp3 carbon. So OH is linked here and next to the benzene ring. The product A and B are okay. So if you know Benzaldehyde Cannizzaro reaction, we will get one is benzoic acid, or that is the salt of benzoic acid, and another is the, so one is oxidized product, one is reduced product. So this one, A is your this compound and B is this compound, right? So what I can write? Sodium benzoate and phenyl methanol. Okay, so correct answer for this question will be option number B. Now let us see next question. Again we have this reaction based. So first of all it is CH3COOH. Okay, when you use PCl5, OH is replaced with Cl group. Okay, so this is A. Now when you treat it with benzene, so this is acylation. So we will have COCH3. Okay, now this is my product B. Now we have treatment with CH3 MgBr. So this is what Grignard reagent. How to do the products of Grignard reagent? See, Mg is metal, this is plus, this is minus. In carbon and oxygen, this is minus, this is plus. Okay, just to separate it. Now minus will attack on plus, plus will attack on minus. So I will get this one like this. CO. O will take MgBr here. And then C will take the CH3 part. And here we have CH3 part. Now this OMgBr can undergo hydrolysis to give you OH. Okay, so I can write here this one as OH. Okay, so now what will be the product if you see? So we have, so there is no C6H5, we can eliminate this option. So we have C6H5, COH, CH3 whole 2, right? So the correct answer for this question will be option number D. Very easy question. Now next is the formation of cyanohydrin from ketone is an example of nucleophilic addition, right? So there is nucleophilic addition is a very important topic. You have some examples of addition of HCN, addition of alcohols, ammonia derivatives. Okay, so please prepare this part. Now iodoform can be prepared from all except. So again this iodoform question has come. There are two conditions, that is one is it should have CH3CO group or else it should have CH3CHOH group. Okay, so these two conditions should be fulfilled. So butane 2-ONE, if you draw the structure, this is butane 2-ONE. Okay, next we have acetophenone. This is acetophenone. Okay, next we have propane 2-OL. So CH3, this is propane 2-OL. Next we have propane 1-OL. Okay, so now you see which group, which compound is not having this one. First group is having my CH3CO group or not. This one is having, so this one will react. Now in the second one also CH3CO group is there, it will react. Third one is this condition, CH3CHOH group is there, so it will also react. But in this question, in this option, neither of the groups are there, so it will not show iodoform reaction. Hence correct answer will be option number D. Okay, now let us go to the last question. Acetic acid is treated with calcium and the product so obtained is subjected to dry distillation. The final product is. So if you have acetic acid, okay, reacting with calcium hydroxide, so this is acetic acid, calcium hydroxide will react with, so we will get like this. Whole 2 of calcium hydroxide, right? Now when you do distillation, so there is dehydration and the product formed here is propanol. Okay, so the correct answer for this question will be option D. This reaction you may not be knowing, so you can just learn this reaction. So the correct answer for this question is option number D. Okay, so yeah, so these were the top 30 questions from aldehydes, ketones and carboxylic acid. It is a very important topic. Please prepare all the methods of preparation, all the name reactions and all the chemical properties from this chapter. Okay, So now I have solved top 30 questions. If you have any doubt in any question, please comment it. I'll be addressing it in my next video. And I also want you just solve these 30 questions. Just let me know in the comment section how many of you have got how many questions correct. Okay, please comment it. Let us see how is your preparation. And then, so if you have found this video helpful, please like, share and subscribe our channel. Thank you.